Hi everyone, welcome to today's lesson. We're going to focus on the CPU, or the Central Processing Unit as it's more properly known. You should have in front of you your worksheet for today's lesson, and it's in the form of a mind map. Where you can see an asterisk next to a blank, those parts you should be able to fill out over the course of this short video. And once you've completed that, you'll then have some time to go and do some research on your own and fill out the rest. I'm going to start by looking at how a CPU is made, and more importantly what it's made from, and how this dictates the way in which a CPU behaves and the way in which it deals with data. Then I'm going to move on and look at the smallest building blocks of the CPU and just how tiny they really are, and how these very small components can be moulded into patterns which allow them to be used for a variety of different uses. We're then going to look at what the CPU actually does. What's its job? What does it do for a living? And then how does it do this? I want to finish by thinking about the speed of a CPU and how that is measured. And once you've achieved that, then your next job will be to go on and actually finish these. So let's think about some key facts about the CPUs. They're made from a substance called silicon, and silicon's found in sand. Silicon is a semiconductor. Now, what's a semiconductor? Well, it's material that changes when electricity passes through it. You can think of it as remembering the state, either charged or not charged, until electricity is passed through it again. And those are the special properties of silicon. So for a CPU, electricity has got two states, current flowing or current not flowing. And of course that's the 1 or 0, which makes that link between silicon and why computers use binary. So these CPUs are made in modern factories. This is the Intel factory here, and you can see that it's a very complex process that involves first turning sand to an ingot, and an ingot then sliced into lots of wafers. And it's on these wafers that you can see I'm holding there that they actually build up all of these transistors into gates. It's a long process, the fabrication process, as you can see, and you don't need to understand all of this, but all of these wafers are whizzed around the factory in these high-tech pods where each process is performed in turn on the wafer. And I guess fundamentally it's that they build up layers and layers and layers of transistors until the CPU reaches the point where it can be tested and then can actually do the processes for which it was designed. This, by the way, is Moore's law, which could be handy for those of you who are looking to do the extension question a bit later on.
Hi everyone! Do you think that every computer has a processor? What about mobile phones? Do they all have central processing units too? You probably guessed that there is a processing unit in every phone and computer. But do you know what a processor actually does? I'm going to set the timer for 30 seconds. I want you to write down in one sentence what you think the purpose of a processor actually is. Your time starts now. Okay, I wonder how many of you wrote something down about it being the brain of the computer. It's something they tend to teach in primary school. It's not really that helpful because computers can't actually think. I guess you could say that it's a bit like the human heart. It's a bit like a beating clock setting the rhythm. Even that's not very helpful, because computers don't have blood, brains, or hearts for that matter. It might be more useful to think about the CPU as a kind of manager who is very good at maths. Someone who controls a team of players. each of whom have different abilities and responsibilities. The manager tells everyone what they need to do at the right time. In simple terms, the CPU is a super speedy calculator and it controls the flow of data. CPUs solve arithmetic sums like adding and dividing. They solve logical problems using Boolean algebra. Logic gates are a key ingredient of computer processors. But what do processors calculate or process? Just as a human brain works with thoughts, and heart pumps around blood, well, processors need computer programs to process or calculate, if you like. Computer programs are of course written in computer code, and there are lots of different types of code or programming languages. Different languages have been created to make different sorts of applications. So we know that processors process code. Computer code contains two types of information: instructions and data. So firstly, there are instructions. One instruction may be to tell the processor to copy a value from X location. Another instruction may tell the processor to add it to the value of another value. Secondly, there is the data itself. For example, numbers that the processor has to manipulate in order to produce an output. Do you remember how we talked about the processor being a kind of manager? That's the second part of its job. The CPU has a special component called the control unit. The control unit not only controls the flow of data inside the CPU, it also controls the flow of data to both the main memory and the input and output devices. So there we have it. Now we know the purpose of the CPU.